Hello and welcome back to another Emacs Science Team tool tutorial video. Today we're going to be focusing on the tool Hardcore, which is a core radius fractions exoplanet online calculator. Now Hardcore exploits boundary conditions on exoplanet internal composition to solve for the minimum, maximum, and marginal core radius fractions, or CRFs, for a solid exoplanet based on mass and radius limits. To go ahead and navigate to the Emacs website, scroll down to Hardcore and hit Launch. That will open up the Hardcore online interactive tool, in which it'll describe to you what the tool does, how it does it, and how to use it. Now for this model to hold true, they make a few different assumptions, including the planet being fully differentiated, the planet has no layers denser than iron, and if the planet has an outer volatile envelope, it has a negligible mass. The boundary conditions Hardcore exploits can be described by Figure 1. Although each planet shown has a different interior composition, the planets are indistinguishable when only considering the observable parameters such as mass and radius. So as you can see on this triangular diagram, the ternary diagram, they have different compositions of different chemicals that are completely unknown to the observer if only looking at the mass and radius. For all of these different planets, which have different compositions, show a mass and radius equal to 1 of Earth's mass or radius. So if the planet has a set mass and radius, will always have the smallest core size if that planet is composed solely of an iron core and a silicate mantle. Likewise, a planet of a set mass and radius will always have the largest core size if that planet is composed solely of an iron core and a volatile envelope of negligible mass, such as this bottom planet example right here, with a core radius fraction of only 0.77. Now in order to make your own planet diagrams, you come down here to the input values. You can name it, so I'll name it my planet. Planet mass, we'll say it has a planet mass of 1.5 Earth masses and a planet radius of 1.25 Earth radius. And we'll submit it. The tool will tell you while the tool is running, it'll say running, and when it's finished, it'll say finished. In order to view it, come over here and click on View Results, which is this little I button. It'll show you your input values, it'll show you the actual output values, and it'll create a plot of the planet's CRF, core radius fractions, with the minimum, the marginal, and the maximum being displayed. Now let's say there's some uncertainties associated with the mass and radius of this planet. I'll go ahead and put in an uncertainty radius of mass and radius of 0.05 and submit it again. And you see that it actually creates a brand new model, not overwriting the old model. So if I click on this new model, view results, it'll show me not only the planet graph that was shown before, showing the CRFs, but it also shows a probability density graph based on the core radius fraction. And it also has new uncertainty values associated with each CRF, min, max, and marg values. This little button shows you the tool, the code associated with the tool, telling them the input values. It's not much information, it just shows you how it's running in the background, and the finished execution is basically what you see under the status icon. Now if you ever want to get rid of a tool or a planet model, you can just go ahead and delete these. And let's run one again with a smaller mass and radius, with uncertainty values of 0.05 again. Submit that. It's running. It's creating it. This one's actually taking a little bit longer. There we go. Click on this, and it shows you that the minimum core fraction is at least 0.658, with the marginal being more around 0.75, and the maximum being around 0.843, as you can see up here with the plus or minus values. Now this looks much different because this is a smaller planet, and so it must compensate for its smaller planet mass and radius by having a larger CRF, which is also shown by these 3 value sections in this graph here. Now if you ever want to use this tool, please feel free to. All of the links are attached to this tool on the Emacs website, and also please make sure you cite the original authors, which is this paper here, which can also be found on the Emacs website. Thanks so much.